Hey everyone, so there is a comment in my last video that ma'am please make a video on nuclear force. I want to know one thing about nuclear force as they don't follow inverse square law. That's true. Then what law do they obey? So that's a very interesting question. That is Millen Shah. So I want to explain you that before understanding what law they obey, let's understand that what is the mechanism between these forces. When the force act between two things, so what actually happened is the property of the force actually depend on the exchange particles between two objects. So if there is electromagnetic force, there is an exchange particle between two objects that creates that force, and the properties of that exchange particle determines the qualities or the properties of that force. Okay, so for the electromagnetic force, the exchange particle is photon, which is a massless particle. Now, as per solution of Yukawa's theory, you can see that the solution come out which follows 1 by r square law. Okay. And also for gravitational force, if it is considered as a force, the particle graviton is massless, though it is not yet been experimentally verified and discovered, but it is a massless, and that's why gravitation also follow 1 by r square law. And it is a infinite range, sorry. But for the nuclear force, the things change. First, the nuclear force acts on a very compact space between nucleons, that is protons and neutrons. Protons and neutrons are themselves composed of quarks bounded by gluons, and the exchange particle between them is pion. Now, pion is not massless. It has certain mass, and because of that, the solution changes, and it doesn't follow 1 by r square law. It follows exponential law, and these all comes from the quantum theories. So, due to the exponential law, the nuclear force acts between in a very small space. It is not infinite force, infinite range. It decays exponentially. For a certain distance, it is more attractive and repulsive, and if you go further, it is attractive. So it behaves very differently. So that is the answer of your question, and we'll meet you in the next video.